Yesterday they put the ice in the radio.
What'd you roll over in your sleep for? Where's that other chucklehead?
Hey, fellas! Hey, fellas! I'm stuck! Defrost me!
Welcome to Did You Know? The ESCO HVAC Show. We will see you in about 45 seconds or so. Make sure that you are subscribing to our channels, LinkedIn, YouTube, Facebook. Turn on notifications, and we are very excited to be here with you. It's almost time, about 30 more seconds. Make sure to grab your notebook and pen so you can jot down notes along the way, because at the end of the show, you could have an opportunity to ask our guests questions so we can dive a little deeper into these topics. And here we go. Welcome to Did You Know? The ESCO HVAC Show. Well, good afternoon, everyone. Thank you all for joining Did You Know? The ESCO HVAC Show. We are so grateful to have you here in our village today. Today we're hanging out with our good friend Jim Foltz from Emerson White Rogers. Jim, what's going on?
Hey, thanks for having me today. This is absolutely awesome, Clifton. And I didn't know we was going to have a intro with Larry, Curly, and Mo. How fitting for what we get to share here today.
Looking at a defrost and like, oh, by golly, we might be able to come up with something about defrost and universal defrost boards. And yeah, that ended up pretty good for that one.
Yeah, well, yeah. I'm just wondering, where's Mo?
Yeah. So Jim and I had a really good time hanging out at the National HVACR Education Conference out in Vegas. Really spent some time talking about, universal boards and universal controls, and more importantly, understanding sequences of operation. And man, Jim, I've been sitting here trying to think about how to tie myself into this conversation. And last night I was laying in bed, thinking, man, what part do I want to talk about? And it came to me, the job that I remember the importance of universal parts, right? So I was about 5 years into the field. So I started in a family business, small family business. We did refrigeration, a lot of commercial refrigeration. We did residential HVAC. We did commercial HVAC. And I was on a job. I was, we did a lot of small family businesses in my area. So in about a 5 or 6 county area here in central Indiana, I took care of every mom and pop grocery store, every mom and pop restaurant. I did a lot of small refrigeration stuff. And I can remember I was at a Friday night, I was at a pizza shop here in central Indiana, and I was working on an ice machine. So I had an old Scotsman ice machine that was down. Friday night's pretty important. So, clean and sanitize, hour job. I stripped the thing down. I knew. So by the time I got it back together, I was waiting for the first harvest, right? So I'm standing there, I'm just hanging out, and I'm talking to Eddie, the owner of the business, and he's a little on edge. And I'm like, what's up, Eddie? He says, I got 2 pizza ovens. One of my pizza ovens is down. I'm like, man, that's rough. He said, on a Friday night in the middle of summer, he said, that's horrible. Said that is, and the guy that's supposed to be here to fix it from Indianapolis can't get here until tomorrow. So I'm in a bad shape. And then he looks at me, and it's like time slowed down, right? It slowed down, and he went, do you work on pizza ovens? Pause. My brain went pause. And so part of my brain is saying, nope, I don't work on those. And the other side of me is going, gas-fired appliance. I've been taught gas-fired appliances are just sequences of operation, just like refrigeration. We just change the controls. So this is Eddie. Eddie's as good as gold. So hit the pause button, come back to life, and go, Eddie, I've never worked on one in my life, but I think I'll take a moment and at least look at it for you and see if there's anything that I can do. All right, it's worth a look. It's a heating appliance, right? Never touch one. I pull the cover.
You bet.
I pull the cover off, and I see a control that looks vaguely familiar. And I go, okay. So let's think about this thing for a minute. It is a, what do we get? Am I natural draft? Am I forced draft? Am I induced draft? Right? All of them are going to have some kind of system to it. I got a thermostat. I got some limits. I have a single stage, direct spark ignition, flame rectification. Hold on a minute. That sounds like a universal intermittent spark ignition system, maybe. Or
there you go.
Hold on. I can use a direct spark. Hold on. Let me go look at something. So I've got this box that's been sitting on my shelf in my van for 3 years, right? Collecting some dust. And go out there and I open it up, and it's a universal direct ignition board. And I go, yeah. I mean, I usually keep these on hand for old natural draft furnaces, but what if, right? So I'll go in, take a look, staring at it, I'll go, wasn't that crazy? Happens to be almost the exact same ignition module, right? So the brain in me goes, all right, this is why I was taught sequence of operation for pieces of equipment. We learn how the thing functions so that we can not only troubleshoot it, but we can look for replacement parts, especially when we're in pinches like that. And when I finally pulled out the instruction manual for it, that original part number on that spark module that had the name of the pizza oven on it, it didn't have any of the manufacturer control, it had the pizza oven manufacturer name on it, was in the list on my universal replacement parts.
Wow.
So once I was later, I thought, man, I had to share that, because that was what really taught me that importance of, I was taught sequence of operation. I was taught sequence of operation for refrigeration systems. And my mentor, he was an amazing man. He taught you, if you learn a sequence of operation of refrigeration, you work on anything. It doesn't matter what size. You're just changing controls and motors. That's all you're doing.
Yeah.
You learn sequence of operation on your gas-fired appliance, boom, same thing.
Yeah.
So it stayed with me all through my career. Even in just a few years ago, I was doing private industrial classes for a big steel manufacturing facility over in Ohio and one in Pennsylvania. And so I was working with these maintenance guys, teaching them, sequence of operation of different kinds of equipment. And at one point, one of the guys says, I got one. I want to see if you can figure out. I said, what's that? He said, step out here. And it had a 1.2 million BTU gas-fired boiler. Right?
Wow.
So we walk out to it, and he's like, hey, how are we going to figure this one out? I said, no, you're going to figure this one out. What is it? What are you looking at? He said, what do you mean? I said, what kind of draft is it? He says, okay, well, it's a forced draft. It's got pressure on the inlet side of the heat exchanger. I said, good job. What kind of ignition have you got? I've got a direct spark ignition. Cool. What kind of gas valve? Well, I've got modulating. All right. Is it electrically or pressure, like vacuum or air actuated? Well, I'm pressure actuated. All right. Good. Have you got any kind of circulation that happens after that? He said, what do you mean? I said, just if we have controls on a board that's circulating a fan, isn't the same as circulating water? It's just an output. Is it a permanent split capacitor or is it an ECM? And he said, is it really that simple? I said, it can be.
It is. Yeah.
If you look at it from that perspective.
And I am so glad that your pizza oven story stopped when it did. I was a little worried. I was thinking that the first lesson to give the new contractors, the techs listening today, was never stand right in front of the burners when you're trying for that first ignition.
First try. See, did I set this timing up right? Is my pre-purge enough?
If you don't learn that lesson, your eyebrows will.
Oh, buddy. Didn't take too many burn-offs early in the career to learn that timing is important. That's what those dip switches are for. I was sitting there thinking about that last night. The dip switches are because different manufacturers just change their timing. Pre-purge, post-purge, ignition timing, trials. That's all we're doing.
So, you always want to stand to the side of any gas-fired appliance whenever you're starting ignition, because that's lesson number one, really. And you went on and was talking about boom, and I was like, oh, there it went. But,
no, it was very successful. And from the contractor side, thinking about it as a contractor or as a consumer, he was a partner for life. So because I stepped out of my comfort zone and I looked at a piece of equipment that I'd never worked on before, and I kept the mindset of sequence of operation, I can do this. It just made a connection that lasted forever. So, all right,
Yeah.
enough of
Yep.
my rant. I had to get that one out.
Oh no, that was awesome. Yeah, that's great. Yeah, I've heard the word pizza oven thrown and tossed about a couple times from you, but I never heard the whole story. So that's
Yeah.
awesome to hear that whole story. So one of the things that I, we was talking, he was like, hey, if you have some slides, send them over. And it was like, well, I got some, they're right here. And so I can put them up here on the screen real quick. The idea was just kind of to be able to go through and give us a path here for conversation a little bit. And I start the whole conversation out with knowing the normal. What's the normal? Is there something that looks abnormal in knowing the normal? Yeah. And that's really one of the biggest keys that we can have in as we go through and looking at universal as that success language of being able to have that universal product out there and available. Right. And so, yeah, it's understanding what that is that's really the challenge. And so let's see if we can keep this thing moving here. There we go. Universal. Why do we want universal controls? And universal controls is something that if you have a universal control, you can fix it while you're. If you're going to your OEM and saying, hey, I need this board. Well, yeah, it's at another branch. We can get it there for you, but it'll be tomorrow. So now your homeowners without heat or air or whatever the issue is. And a lot of times the cost of the aftermarket parts can be less expensive than the original. Now, I say aftermarket parts. I want to clarify that. Something that I heard at the ACA show here earlier this week was the comment that when you talk about universal parts, it's a little scary. But when you talk about universal parts that are made by White Rogers, there's a lot more comfort level in that because of the fact that that the design and the quality is there, that you can take care of things. So you can be able to fix something fairly rapidly and potentially at a lower cost to you. You can keep that savings or help pass that on to the homeowner.
And many a time, the same manufacturer. I go back and look at my board. When I take that pizza oven sticker off, what's in there? There's a White Rogers.
Yeah. Oh, yeah. And we've made boards for quite a few different manufacturers through the years. So, yeah. And so that's the two benefits. That's the why. Why do I even want to mess with Universal? Well, do you want to spend the time and the gas to go to the supply house and try to get a part where you could have something that's with you? And you're not driving for that. You're not throwing money away. You're repairing while you're there. You're making it on that same trip. And that's the whole reason for this conversation is the benefit that you can get out of universal parts. If there's no benefit, then there'd be no reason for us to even go through some of the options and the thought processes with getting to universal. And it takes being able to understand where you're been to be able to say, yeah, this is something I should really consider is a universal option, a universal part.
Yeah. For those of you out there that are educators, many of us, we ended up educators because we were good at what we did in the field. So I'm asking two things of you. Let us know where you're chiming in from, and let us know if you stocked universal parts on your vans. Because a lot of people are kind of torn in that. Well, do I go back with OEM or do I go with universal? And I will tell you, I stocked my van full of universal parts because of this particular kind of scenario. So definitely let us know your opinion on, stocking universal parts. And even in the classrooms, do you talk about universal parts as we're educating sequence of operation of equipment? Because I think it's very important.
And it is. And that is one of the things that I like to share too. If you're an educator and you have equipment in your classroom that is going to be the real life application, the 5, 10, 15-year-old pieces of equipment, a lot of times you can double your syllabus out of that piece of equipment. You can do the training on the OEM part, and then you can go back and do the training on a universal part and have both in as a part of that training right there in the same piece of equipment. So you're increasing your class time, length, and ability to be able to go through things. Well, and what's the difference? Well, we can get to that a little bit. Let's keep going here. Where you start, and this is the biggest thing that I find that we deal with is this right here is what's scary, and right. Be interesting to see if we get the animation to play there a little bit.
There we go. Yeah.
You know, is it really scary, or is it a walk in the park? And that's what my goal is to help share contractors, technicians, educators, whoever it is, how to make working on equipment a walk in the park, whether it's using universal or not. There's a system, there's a thought process that's been beneficial for me in the 34 plus years that I've been applying the trade of HVAC. That's why I'm where I'm at. Just like you said earlier, is because it's something that I can share and go on and share with and help. So what we're looking at is, and you just went through this with the pizza oven. Believe it or not, everything, you took my slide away, Clifton.
I'm so sorry. Well, no, it's a perfect analogy, right? This is great.
Yeah, you bombed it. This is it, folks. If you want to work on a gas furnace, you're pretty much out of parts besides what's here on a standard single stage 80% gas furnace. Yeah. You can get some more parts in modulating and 90%, but a lot of times they're replicates. There's additional limit switches. There's additional pressure switches. Right. But as far as the main parts, this is what you're going to deal with, folks, when you're dealing with parts. So are you looking at the whole picture? Or are you saying, oh, well, I look at this by itself, and understand that on this page we got what 1, 2, 3, 4, 5 low voltage pieces on here, including the thermostat, the IFC, which gets 120, but it also controls the 24 volt, as well as the transformer, which gets 120 and sends out 24 volts. And then you got the 24 or 120 power coming in, the igniter inducer, which are 120. Whoa. Erase that. Let's back up there a minute.
That's a good call. I was hopping in, but you got it.
Yeah. Thank you very much. So, and then the blower motor is 120. Finally, this little nice piece down here of the flame rectification and being able to understand how that flame rectification works. That's typically somewhere around 120 volts on that as well.
Yeah, that's a good one. A comment just came in from Matt. Matt, thank you for mentioning that. So what advice you give apprentices first year on retaining electrical? Here it is, my friend. So Matt, what we're trying to help understand is when we're talking about electrical troubleshooting, right? When we're talking about electrical troubleshooting, we can follow that sequence through many different pieces of equipment. Let's just take this particular scenario right here. If we learn this sequence of operation of a gas-fired appliance, and what I like to have in my classes, especially if it was on an installation class and a tear-out class, if you have different manufacturers of furnaces all next to each other, let's just say they're all 80% single-stage furnaces with PSC blower motors, right? And we have one universal control board. I can walk down through each one of those different furnaces and show that control board can function on any one of these brands, even if the wiring is set up different on the furnaces. Prime example, take like a Goodman furnace. A very, very common thing that happens on Goodman furnaces, it gets overlooked by a lot of technicians, is when we leave our transformer and we have that 24 volts coming into our control board, a lot of times a Goodman, the limits are before the thermostat connections, before the R connections on the control board. So there is another little loop of limits that comes out and then goes back into the control board immediately. And another brand of furnace may not have that. So all I would need on my control board is a way to be able to jump through on that particular one, which is why we have the different jumpers, the different leads, so that control board can work on different pieces of equipment. So electrical troubleshooting is just kind of like what we're talking about. Start on our high voltage, follow the high voltage, and follow our low voltage. And now we can connect piece to piece to piece through different manufacturers because they're all following a sequence of operation. Good question.
They are, yeah. Yes, thank you. Appreciate that. That's and just to kind of add on to what Clifton was saying on our slide here, right here, there's the thermostat, which is electrical switches that's going to power things on or send that signal to the control board of telling what to operate. Your pressure switch is just a switch. Your limits, they're just switches. They're just open and closed. That's all you have on those. The only other thing you have on the low voltage side is the gas valve, which is actually a load, which actually takes that 24 volts and allows the gas to go through it when it's energized. So understanding what the component does is going to be a huge help. And as we go through these slides that I put up here for our conversation, I think it'll hopefully become a little more clear to you how to look in this first year of electrical knowledge and see what you're dealing with. And the more familiar you are with each of the controls, what they do, the easier the electrical is going to come.
Oh, absolutely.
A lot of times we kind of have blinders on, thinking electrical is something big and it's a really rough challenge. Yeah, and in reality, it's just a path for current to go through. And if we understand what each piece is doing, how it sounds, how it functions, what to expect from it, if we understand it in its entirety, when we get to the electrical troubleshooting, it makes the whole thing easier. And that'll kind of tie back in to our opening slide there.
Absolutely.
In what we know and how it applies into what we're doing. So hey, let's keep going here. We're going to burn up a whole bunch of time here.
Yeah,
a couple different things of helping you in categorizing things. I like to split a furnace into two parts.
You betcha.
The burner area and the blower area. They're separate. There's a plate that separates the two. Most of the time is two separate doors for each one. On occasion there's one. Then there's some other special applications with that. But the burner area is responsible for making the heat. The blower area for distributing the heat. And typically you will always find the list here of the components in the burner area in that location, and the same with the blower area. And so let's look here. How many things do you have to memorize on a gas furnace?
Not a lot.
Inducer igniter, flame sensor, those are 3 120 volt circuits.
That's right.
Gas valve, pressure switch, limit switch, there's 3 that have to deal with the low pressure. We're out. That's it. So it's not it's something that there is
a short list.
The first thing to do is to get your mind around the fact that there's an end to the amount that's in there. If you understand the whole picture, then it's a lot easier. If you're always thinking, well, there could be something else in there that's not functioning or not working, but understanding this is all it can be. It has to be in somewhere in this. That really helps in that electrical troubleshooting and knowing the limitation of everything that can be.
Yeah, I mean,
blower area.
If we move this into, say, a 2-stage or a modulating gas furnace, all that we're going to be doing, if we take that exact same side on our inducer, we're either going to go from a single speed motor to a multiple speed motor or a variable speed motor, all tied back to the board. If we talk about our igniter, that ain't changing. Talk about our flame sensor, that ain't really changing. Gas valve, same thing. It's going to be a single stage, or it's going to be a 2-stage, or it's going to be a modulating. If it's modulating, it's modulated off from vacuum, which is just adding a hose, or it's modulating off from a variable DC voltage off from the control board. So back to the control board. We're not adding a ton of extra stuff.
Sure. And you say, well, wait a minute, Clifton, we got 3 wires going to that inducer now, not 2. And now I got to figure out what else is going on there. Well, so, but the sequence of operation never changed.
Still stays the same.
If you are making a call for heat, the first thing that has to happen is that, well, let's back up. You could have a internal thing that you can't see, and that is that the board could be checking to make sure the limit switches are all closed and that circuit is done.
Exactly.
But the first thing that you're actually going to be able to notice a noticeable change is an inducer motor is going to start. It's going to be sight. It's going to be something you can see.
Something you can
Doesn't
hear.
matter if it's a single. Yeah, don't matter if it's a single stage or a 2-stage inducer motor. When it's time for it to come on, you're going to be able to see and hear it come on. If you don't, you know that's where you start. Your first thing is you've caught it with your senses. Now that you know it's not coming on with your senses, now you get to go and pull the meter out after you've determined this isn't part of the sequence that's functioning the way it should.
Sure.
And from that, then you can start using your meter to see, hey, is it getting 120 volts to the speed that's supposed to be running right now?
Sure.
So again, just being able to understand these are the functions, these are where they're located, and this is the whole picture. There's nothing else. I'm trying to make this as simple as possible to understand where we're at. And here's something that's changed over the years. The bottom left corner here,
good call.
Spade connectors. Those spade connectors. When I started in the industry, it was relays. It wasn't.
We might have been pre-integrated control boards, but we're not going to say that we know how to troubleshoot them. But we know how to troubleshoot them.
there you go. Yeah. But we started getting these printed circuit boards, and they had spade connectors on them.
Yeah, absolutely.
And then the manufacturer's like, hey, we can make this simple. These are all 24 volts. Let's put them all together in a plug so that they can plug in. And early plugs was 2 and 4, 6 pin plugs, 9. Now, most of the time we see a 12 pin plug or a inline plug. Carrier Bryant ICP uses the inline. Goodman, Train, all of the rest of the brands use that 12 pin Molex setup. So that's what we have today, which makes it a lot easier in understanding what's going in these. You'll always find 24 volts in these. I don't know of hardly any instance where a manufacturer would put 120 volts in one of these plugs along with the 24 volts. The only exception to that rule is the flame sense current signal can go through here, but the 120 volt signal from that, the amperage, the microamps coming from that's lower than the 24 volt signal going through. So there's not a concern of having too much of a charge through that. And so here we are to today. Today we got the 12 pin or the 11 pin inline, and we're just monitoring the same list that we've already talked about of components in these gas furnaces. And the fact that 120 volts, you can get 2 or 4 pin plugs, but the bigger plugs are always the main low voltage. So that's what we have on our OEM boards. Mm-hmm. Let's look at the low voltage circuits on a universal board.
Okay.
All of those pins, this is our new 56X that we just launched here.
Yeah, I don't think recently. I've seen that. I'm not actually messed with it yet anyhow.
And all of those low voltage circuits are going to plug in to one of these pins down here. And one nice thing about this, we used to have harnesses with this, and then you had to figure out which harness you needed.
Absolutely.
Now there's no harnesses.
You've eliminated all of the harnesses that comes with it?
We got rid of all of them. You don't get a single harness in this box.
All right, so this is a direct plug-in.
Oh, it is, yeah. And it doesn't matter which one of the 7 brands you got. If it crosses over to this, and we'll go get into the cross-reference later on, but you just simply plug it directly in. And so you don't even have to worry about which ones are going in on which. And again, these plug-ins, they're just dealing with those low-voltage pieces that you're working with. The transformer, on occasion, they'll plug in, but we also actually have spade terminals on the board that they can be plugged in directly, because a lot of manufacturers do still do that. That's all the low voltage circuits on a universal. We got the thermostat. We'll cover that in a little bit. But as far as the furnace itself, we've covered it. High voltage circuits where the power comes in, goes the transformer. The inducer igniter on this board, we have 4 different plugs up here, and we have spade terminals that are marked inducer and igniter if it's an older one with just spade terminals on it. But those 2 pieces, I like to tie them together because they're the 2 other motors that are loads, I should say, not motors, in the burner compartment. Yeah. And a lot of times they're paired together. If there's just a 2-pin, more than likely one of each of those wires is the 120 volt power hot. And then there's going to be 2 white wires with spade terminals that go in, and we actually have a whole row here along the left side of neutrals. They're all tied together inside the board, so it doesn't matter which one you hook up to. They're all the low voltage there. So the PSC blower motor goes right at the top. There's fan cool heat. Mm-hmm. It's all right there. So everything 120 volts all together, all united in one spot. Okay. And it just makes it so much easier. And then other additional circuits. Now this board actually does both PSC and ECMX or X13. So there's
I was going to
the
ask you because I see the
lines-
4-pin connector on the load side over there on the left. Does that do 2-stage draft inducer?
So this right here,
Yeah.
or down here.
Yeah, that 4-pin there up top left.
No, it would be the inducer and igniter, power and neutral.
Okay, gotcha. All right.
Yeah, hot and neutral for both of them.
So single,
which a lot of
single-stage
manufacturers
unit,
are using that. This is all single stage unit. There are some Goodman hybrids out there that this works with, and they're listed. They're called out both in WR Mobile and the installation instructions.
Which we'll get to that here in a little bit too. I built a QR code for WR Mobile, so we'll come to back that one here in just a little bit.
There you go. So all your ECMX, they're all here, and then your thermostat bus, which comes off, which makes it super easy to plug in. So how hard is Universal? We have pretty much just covered the majority of this board in just a few minutes. And so how do you go about understanding and working with that? Well, it's kind of like understanding circuit spaghetti, and this, I kind of get a kick out of using a roadmap yet, because for everybody that's on board with this today, that's under 25, is like,
a what?
What is that? That is what
we just bought a brand new one. You can still get them on Amazon, up to date. So we just bought one about 3 months ago. We were taking a road trip south, and I thought, and I'm kind of I live in this bubble. Howard will laugh because I live in this like crazy bubble. I love technology. I love our industry. I haven't had cable television in like 13 years. I went to Costco for my first time last week. So I want an Atlas to go with us when we're on the road. And there
you go.
So they're still out there. You just have to know how to read them.
Yeah. 2015. Took my family from California to Ohio and back 21 days,
Nice.
24 states, and a iPhone 8, I believe, was what I had at the time, with Google Maps. Not an Atlas, not a map in the van. The whole trip.
Wow.
So if you're younger and you're looking at saying, what does this have to do with me? I understand. It's just simply the idea that you're looking for the path to get you from one point to the other. And sometimes it just means tracing one wire at a time. I had a company, a printing company, that had all kinds of HVAC equipment to cool their printing press rooms and everything. Sure. And on a rare occasion, the owner would say, hey, something's not working right in the cooling system inside the German-made press, which has a schematic, but everything's in German. Right. And so you get to sit down and you trace one wire at a time till you find that relay that's not closing and replace it. And he was thrilled because I saved him the cost of a technician coming from Germany to figure out one relay that's in there. But it's one wire at a time, and that can take time. I understand that. That's the challenge of having the patience and say, I need a starting point and I need an ending point to be able to trace through that and understand and see how that's done. And these here are examples. A limit switch circuit. You find the limit switch circuit on your schematic, and then you just start tracing, and you can trace to your pin connector, and then trace on around through the circuit, see what other limit switches are in that circuit, and continue to follow that around. And this is a slow slide. Wow. Uh-oh. And we finally get there.
Hey,
pin 1, pin 7 is a, this is kind of something you talked about earlier, that limit circuit going into the board.
Yep.
It leads one, goes through, and comes back. Most furnaces have these. How they operate could be different. And I say that because some of these are just monitored, and if there's an open switch, it will not allow the sequence of operation to start. It was a number of years that Carrier actually put this circuit on a normally closed fan relay. So when you powered the furnace up, the blower started blowing and would not shut off.
Yep.
And until it recognized that this circuit was complete.
Yeah.
When it saw this circuit was complete, it energized the relay, opened up the normally closed contacts, and it shut the blower off. So it was designed so that any time that a limit opened up, that the blower would be running to help make sure that something didn't overheat.
Yeah, absolutely.
And so it's just a matter of following that one circuit by itself. And thanks, Sam, for the German comment. If I could think of the correct response to that, my German's like this. I don't know very much, enough to be dangerous. And we're going to skip this one. This is the same thing,
Okay.
just for time, just one wire at a time, because
Yep.
I want to get to this. And this is kind of the crucial part of really our universal conversation. And this goes all the way back, Matt, to your question of good advice, of understanding. And what happened to me in trade school back in 1989, somewhere back in the dark ages, we were given a gas furnace and with some type of an issue in it and say, hey, troubleshoot it, fix it, and then let us know when you're done. Well, as soon as you're done, you turn around and go to the installer, say, hey, I got it fixed, it's working. And what I would like to encourage you to do is to listen to it after it's done, to cycle it, to watch what's happening, to watch what's going on in it. And this right here, this slide kind of gives you that bit of understanding. And I thought this was really interesting. If you was to be hired as a teller at a bank, they wouldn't give you counterfeit money to study to say, hey, if you see one of these, let us know. They give you the real thing so that you can actually understand what the real paper feels like, what should really be on it. And
The smell.
that's where when you, and it goes back to, well, I got 5 years experience. No, I only got 1 year experience, but the company that's hiring says I need 5 years experience. You know what they're looking for? They're looking for somebody that has done enough jobs and left enough jobs that they've heard over 5 years what the real deal is supposed to sound like. Because if you know what it's really supposed to do, then the fake just pops right out. The unusual, the piece that's missing stands out really easy. So my encouragement is to get familiar with what everything is in real time. Pressure switch. When a furnace is starting, the inducer starts and then the pressure switch closes. You realize that the majority of the time you can hear that click. You can tell with your hearing that pressure switch closed. If you're not hearing that and then your ignition isn't starting up, then you already through visual and hearing know this is the circuit that I need to trace. And so same way with the gas valve. That gas valve, when it's energized, it clicks. You can actually hear it. And those are the types of things of knowing what it's really supposed to sound like, what it's really supposed to do in its function, in its look, how it sounds. That's your biggest key in being able to troubleshoot faster is through that listening and seeing of each piece.
You know, Matt just asked a question before we get too far out of here. Says, are there any good sites or links for electrical courses for troubleshooting? Matt, that's actually a big part of why we're here. So here at the ESCO Institute, we have a variety of sources for you. So I'm going to point out a couple of them real quick. If you go over to our main site, www.escogroup.org. That will get you into the ESCO main website. Now, if you're interested in interactive and e-learning courses, then you go over to the e-learning network. So hvacr.elearn.network. And that's where you can hop in for a variety of different e-style learning. So we really appreciate you joining us and asking about that as well.
I didn't know if you wanted to put up a slide to show that or not.
That'd be a good one. I can come back to it and maybe try to add one here in a little while.
That'll work. So let's get back to get back to our.
Oh.
Yeah. Well, no, we're going to this. This is the full view screen. This is in the presentation, but I wanted to share it in the full operation here.
Yeah.
This sequence of operation. One of the things that I don't show is the behind the scenes after the call for heat. That first thing of making sure that all the limits are there and being checked out and actually enclosed how they should be. And after that happens, then we actually have the first thing that you can actually see and watch. So I'm going to run through this real quick, and I'll see if we can get some sound here with it. This is just a little standard operation that I put together a couple years ago here. So let's see if we can get this going here. And that, folks, is the whole operation.
There you go. Now, that didn't have the audio, but you send that over to me, and I will plug that whole video in the edited version.
Okay, yeah. No, I could hear it on my end. It's like I'm not sure of technical difficulties there, but
No,
yeah,
right.
we will get that all the way through, so everybody can see that. Let's head back to the presentation here and get finished up with it. We're wrapping up what I had together, and we can just finish out then with any other questions anybody has or conversation. Get to know those sequence of operations, those timings. Again, knowing that sequence, how that works, makes Universal so much easier. If you know exactly what your timings are, you can understand, hey, this Universal works in place of that. And Universal can be kind of scary because a lot of times it can mean that you have a lot of settings and a lot of things to deal with. And back to the 56X, the 50M 56X 843 that we showed earlier that I got here in my hand. A couple things about this. One, when you first power it up, it will sense whatever harness is plugged into it and configure itself. So first of all, it's Universal, but you don't have to tell it what you're connected to. So you've eliminated that communication or input to it. The only two things that you need to put in when you hook one of these up is one, whether you have a X13 or a PSC blower motor.
Sure.
And the second one is your delay timings, which you would have to do if you had an OEM and you were matching the heat off delay settings. You would have to do that on that. That's all you have to do with this. That's the extent of Universal configuration that's required on 99% of the installations of these. So
sure.
Eliminating all of these other steps and things of having to know exactly what is on there, what's happening with that. Yeah, they are as simple as you can get. Knowing your operation there is something that's going to be very, very beneficial for you. Let's finish up here. Methods, looking at these IFC wires in groups. We've talked about this already. We have the blower motor group, whether it's PSC or X13. We got the transformer group. We have all the low voltage group. And I say groups because a lot of times what you want to do is, I got the old board here. I'm pulling one wire off and I'm putting it over here. And we do that because we don't really know what's at the other end of that wire. But if we know these are all blower wires, let's pull these blower wires off and set them aside as a group.
Yeah, exactly.
We know that this is the igniter and the inducer wires. Let's set them over here together. This is the Molex plug or the inline plug. Let's pull this down here by itself. If we pull things, if we understand the components and the groups when it comes to using a Universal product, it's just a matter of taking those same groups and putting back on a board. Yes, it looks a little different, but it still has the same type of group configuration that you're applying to. And there's such little amounts of those as far as groups where, to get them messed up it's possible, but we make it as simple as possible. If you know what to do, if you understand what they do, how they sound, what their operation is, you'll know where they go. And so knowledge of understanding, getting familiar with what they really are really helps.
Yeah.
A couple other things of universal.
Yep.
Methods, power versus no power. When do you want to use voltage? Well, when your voltage is already on, it's safe, and you can verify that you're not getting response out of something. In other words, your igniter's glowing or your sparker is sparking, and you should have gas coming on. And by standing over to the side, you can put your leads on your gas valve, and you should get your 24 volts on it when that gas valve circuit should be energized. If you're not getting 24 volts, it's back somewhere else. If you are getting the 24 volts, hey, the gas valve's getting a signal, it's not opening. And at that point, you got to have a gas valve issue. Your final verification, the only other thing you can really do on like a gas valve is to put a manometer on the outlet side and see if when 24 volts is applied, if any gas is coming out. The actual coil of gas valves now, early days, and we're talking
used to be able to check them.
Ago.
Yeah, dang things have got diodes on them today.
They were AC coils, and when if you remember them back in the day, when that coil was energized, you knew it because not only was there a click, there was a the thing hummed. They were loud.
Sure.
And so going to DC coil eliminated all that sound, but there's a bridge rectifier inside of a little board on the top of all these gas valves now that make it impossible to actually test whether or not that valve is opening or closing, if the coil's good or not. So you're
no more
only
checking resistance. You used to be able to check resistance on them very easily.
Yeah. Yep. Yeah. And then continuity, measuring that when you got something tripped. And this picture here, I actually show there's a little wire that's skinned there. Again, your visual and actually checking wires, and a lot of times when I'm out on a piece of equipment that had a blown fuse, I was using my hand to gently move wires away. Half the time there'd be a little black mark on the sheet metal where that arc was, and then you could turn the wire and there it is. That's where the insulation rubbed off. And so again, the visual came to the actual troubleshooting. The meter and the electrical side of understanding what was going on there was secondary. And any of your electrical circuits, being able to use your hearing, your sight, and hopefully not your smell, especially if it's your eyebrows, that you know what's not going on.
Don't let the smoke out.
And here I'm talking about this, and we're already covering methods of listening, feeling, observing, things that you can do in checking all of what's going on. And if you understand everything, again, universal's a walk in the park.
Yeah. Other
thing to listen to, customers. They are a huge help. I'm going to sidetrack rabbit trail.
Oh yeah, rabbit hole time.
Rabbit trail.
That's my typical show. It's okay.
Difference between a doctor and a veterinarian.
Oh.
Yeah, this is a good one. A veterinarian, when they go out to look at an animal, if there's something hurting that animal, it's pulling, it's moving, it's not afraid to say, this hurts. Doctor, sometimes like, oh, I'm fine, doctor, there's nothing wrong with me. And so the doctor has to try to figure out, well, what really is wrong with you, because and as humans, we kind of hide what's going on with a symptom or something because we don't want people to know it. Animals don't do that. Animals show what's going on. And I lead that into the HVAC system. When you're called out on a job, the homeowner is more than willing to tell you what they've heard or not heard, or what something sounds like is doing. We have the veterinarian advantage of being able to get a lot of information from that homeowner of what they're experiencing before we do anything else with our listening or our senses. So another great source of information of where to get that. Value of understanding components. Well,
buddy.
if you know the real deal, you know the real deal. When what's not real shows up, it'll pop out at you. And that's where you want to accelerate that 5 years experience. Start getting more and more familiar with what it really sounds like, what it really is doing, and understanding its real function as you go through it. And that will help with make universal so much easier. I got a couple slides here just to finish up.
Yeah.
On our side of things, universal, we got universal igniters, a universal flame sensor. The non-integrated controls, we have a universal all-spark as well as a fan timer, and we also have a universal hot surface igniter board. I don't have that picture on here as well. But then our integrated furnace controls, a lot of universal there. That the new one that we just talked about, over 550 different SKUs that it crosses.
Wow!
So a huge bit of crosses there. And then we have a retrofit kit for the intelligent valves that are out there that you can't figure out whether it's the board or the valve. This kit replaces the whole thing and eliminates that valve, putting a standard gas valve in. So.
All right.
What you're seeing here, over 2,700 SKUs crossed on this one page of universal parts. And gas valves, we do the same thing. There's over 1,600 SKUs crossed on this one page here of these 4, 8, 9 different gas valves. So being able to have those universal parts on your truck are an absolute huge help. To be able to know exactly what's going on and fix it with the part on your truck. Where to find, and I think you're going to have a little bit more as far as the QR code to be able to access this as well. We have an app that you can cross-reference a White Rogers part number, an OEM, or a competitive part number. You can put those numbers in this app, and it will show you everything that we have out there that it will cross to. You can also search by product, by whatever product you have, if you want to do the search that way.
Wow.
When you get to that search, you get the description, you get links, you get spec sheets, you get cross-references, you get installation instructions, you get installation videos on several of the newer parts. We're continuing to build out the videos for those.
Excellent.
The nice part about the actual installation instructions, if you're out on a job and there's an older control in there, and you don't understand how it's configured or how it's set up or needs to function, you can put that older control right in on this cross-reference and bring up the installation instructions right there on the job site on your phone and be able to understand exactly what you got and how it's supposed to function. So a lot of good information right out there, really easy at your fingertips for all of our universal controls.
Man, I see that as a really good in-class exercise, right? So we've got a couple different universal control boards sitting over here on the counter. We have this particular furnace that we're working on. This furnace needs a new control board. Use your app. We're always talking about ways to introduce technology into our classrooms. Here is a perfect opportunity. So anyone, you can scan that with your phone or you can screenshot it, come back to it later. This will get you a link right into the app. If we have the opportunity to introduce technologies and introduce applications into our programs, it gives us a connection with our students. So we've got a furnace sitting over here that we're working on. Okay, we need to put a board in this thing and go, right? Allow the student to use the application, the apps, to be able to pick a model, pick a part, walk to the piece of equipment, see what they have, look up the replacement, go find the replacement and see how to connect that, and then install it and see if the thing actually works. We're doing so much in that process of troubleshooting and equipment installation and sequence of operation. So I always encourage using apps in the right application. And this is a
there you go. Yeah. Yeah, and more classroom apps. If you was to use something like our 50 M56X 843 in a classroom application,
There you go.
there's another app that you can actually load on your phone. And our apps, by the way, they are no register, no login, no
Oh,
fee to be
nice.
a part of. It's all right in there. And this app, you actually are able to scan this control and do all of your calculations for your blower timings. Like I said, PSC or X13, or
Right.
whether or not it's what your heat, cool, or fan on and off delays. You can set all of those up with an app as well. So another opportunity to use an app to be able to do configuration. And one final plug that I love about this, and that is, and we didn't talk about much of flame rectification, which is another subject that I
It is
dearly
one of
love.
my favorite topics.
But there's an LED screen here on the bottom that if you don't use the app for setup and configuration, you can do it with 2 buttons and the LED screen. Yep. The screen, when it's in the heat mode, it will
read microamps?
Flash. It will read HT. Yeah. It'll flash between HT and then C, which stands for current, and the 2-digit number like 4.2 microamps. Right. So you don't even have to pull out your meter. When this is in the furnace and it's in the heat mode, you can see exactly what your microamps are while it's in operation in real time, and pull that right directly there. So yeah, it's one of the neatest, the coolest pieces of the new control is that microamp feature. So William, appreciate all your comments.
Yeah, man, I'd love to connect with you, William. You get a chance, see Beck at escogroup.org. Let's talk about that, because these are the tools that we're trying to encourage our other educators to use. I mean, think about the opportunities that we have there. If we want to teach flame rectification, it's a difficult thing to teach a newcomer to the industry. It's a difficult thing to teach someone in the industry who is stuck on reading millivolts, that we're not using that current. We're not producing voltage. We're measuring current that's being produced in the board that is a high voltage AC coming through our rod, making its way to ground. You want to teach flame rectification. Utilize this style of a board where we can see it. I mean, I love to teach it with a meter, but if we want to show it in quick reality, the differences, now's a good chance to have your meter to show how to read microamps, show it on the board, have a couple different flame rods handy, one really nasty corroded one that's nice and clean, and we can show the difference in the current flowing through, say, a dirty burner, a dirty flame rod, a poor connection, a bad crimp, a melted wire, and show how quick changes can affect that microamp reading, and show how it drops out when it gets low. So, man, great learning tool.
Yep, it is. It is. Well, yeah, that concludes everything that I got on the presentation here today.
All right,
Cliff. So
that's good stuff.
We've covered some pretty major ground there on universal, and once you get your mind wrapped around that, and as a former contractor, I'm in the boat with everybody else. It's like, there's some universal controls out there, and 4 years ago when I was looking to work with White Rogers and talking with the director of electronic controls at the time, he looks at me and says, "Do you know that we have over 40 aftermarket universal controls?" And I'm like, "No, I'm a contractor. I had no idea." And he looks at me and says, "That's why we need to hire you, is because we have so much out there in the universal realm." And what I share today, like this is covering all manufacturers. But if you're in an area that's got specific, the main dealer in your area was Carrier or Goodman, we have a set of controls that are specifically made for some of those pieces of equipment that our main universal don't cover, that we've made specifically for applications within specific brands. They're still universal. They still may have, instead of 550, they still may have 60 to 80 different SKUs across. So they still cover a lot more boards. And if you're in that market, that's a great place to be, to have those types of universal controls as well. So a lot more out there and a lot more available in the universal side that save you time, save you money, and that's what it's all about, is to make the company that you own or you work for the most profitable
efficient.
it can be.
We keep coming back to
Absolutely.
this. Our big goal is to help make our industry efficient, more efficient. So they're all just tools to be better. Whether I'm an educator and I'm trying to teach my student and I'm trying to be more efficient with my time. Whether I'm a student trying to learn how to electrical troubleshoot and what kind of parts I need and what parts do. I want to be more efficient. Am I a contractor that's looking for ways to reduce my callback time? Universal is the way to go. I say it in a service department, if you're not stocking Universal, you're not profiting. Unfortunately, it's just kind of the reality of the industry. So here's another opportunity. If you want to connect with White Rogers, this takes you straight into the Emerson White Rogers website at climate.emerson.com and takes you into the White Rogers portal. So I'll keep that one up here. Any other questions or comments? Good stuff, guys. Yep, Dirk, thanks for joining us, buddy. We appreciate having you here. We got to run too.
Yeah.
We're right about an hour. All right.
Yep.
Well, cool, everyone. Thank you so much for joining us. We appreciate spending time here on Did You Know? And on our way out, I have a outro video that is it's a prelim of another learning opportunity that we're getting ready to have in the next week or so. Ooh. New podcast channel coming to Did You Know? And our good friend Jim Foltz is going to be one of the introductory podcast episodes. We recorded one while we were out at the HVACR National Education Conference. And so, yeah, thank you all for being here. And we'll see you next week on Did You Know? The ESCO HVAC show. I am so excited to tell you about this new opportunity. We're launching a new podcast channel. Did you know? The ESCO HVAC podcast. It's going to be a lot of fun. We're having 15 to 20 minute stories from our industry, and there will be 5 different flavors of stories for your listening entertainment. Windshield Chronicles is a mental sequence of operation to prepare you for a job or a scenario. Tales from the Trenches? Yeah, that's the horror stories that we have learned out in the field and in the classroom. Soften Your Senses, that's different ways to become a better speaker, listener, and follower. Teaching the Unteachables, well, that's ways for teaching and for learning. And Welcome to the Future. Those are the technologies and innovations that sculpt our industry. We are so excited about this opportunity, and we encourage you to join us.